Hello guys, welcome back. So today we are going to discuss about the quantum realm. So in this video we are going to discuss about the concepts of quantum realm. Why does this topic called quantum realm do exist in this universe, in this world? So in this video I'm going to make you understand what is a quantum realm, why does it exist, and what is the concept behind this called quantum realm. So let's start with the introduction part of quantum realm. So quantum realm is a basically part of quantum mechanics. So quantum mechanics describes the nature at a very small scale at the atomic and subatomic levels, but quantum effects have been observed in large molecules as well. Means the quantum effects have been seen in smallest of the smallest particle as well as the large particles that are made of billions of atoms. So the idea that our everyday world is made from small particles which we call atoms. You are familiar, you may be familiar with the atoms, which are the small. If you start breaking anything in this world to uh, this to its smallest level, then we get the substance called atom. So atoms, the name atoms are given to atoms from the ancient Greeks. It has been come from ancient Greeks. Today we think atoms. Today we think of atoms as small spherical objects that are 10 billions of meter in diameter. Means they are 10 billion times smaller. If we if we compare it with a 1 meter substance, then we can imagine the the size of an atom, that how much small it is. So it is a 10 to the minus 10 10 to the minus 11 times smaller than the size of a 1 meter object. So so common is that it has a special name, the angstrom, and the special symbol A that you are able to see here, that is A symbol is there for angstrom. Objects that are angstrom size have very differently than objects the size of every objects like tennis ball and automobiles. Because humans grow up looking at the and manipulating everyday objects, most people do not have any intuition about how angstrom size objects behave until they have been educated in modern physics. So yes, more in today's life we don't care about what is the size of an atom. We have to other stuffs to do. So that's all they are trying to say. So while Democritus of Alberta came up with the idea of atoms more than 2500 years ago, and our understanding of chemistry has evolved over many centuries. Our understanding of quantum mechanics was developed mostly over the past 125 years. So it is a new topic for us. For us means say for us, what I means to say is humans. It's a very new concept for us. It's only 125 years ago we come to know about the quantum mechanics and quantum physics. Information theory concerns how information is stored, communicated, and qualified. Although humans have been storing and communicating information for thousands of years, our mathematical understanding that information actually is dates of paper by Claude Simons from 1948. A mathematical theory of communications, among other things, the paper introduced the term bit, short for binary digit, that we all know what is a bit. It is the form of, it is like a, what we say, it is like a container, it is like a small box where we store that digital information, like how you are able to read any of the information that is on WhatsApp, Instagram. So they are basically come from the smallest of the smallest level, that are 0 and 1. So if you write A in your phone, in your PC, or in any machine that is digital, so that A is stored in a container called bit. So bit has a size of 8. So what I mean to say, 8 it can store 8 8 numbers like 0 1 0 1 0 1 0 0 0 1. So like that, but the number operating system work only for 0 and 1, and we can make different patterns of 0 and 1 and store that thing in a bit as a fundamental unit of information. Much of what is known about the nature of information, including codes, compression, and encryption, was first worked out in 1940s. As its name implies, QIS combines these two disciplines. Broadly, QIS is the study of approaches that combine knowledge of how quantum effects have been used to measure, sense, communicate, and compute. This appendix is the first of two that are intended to provide an introduction to quantum mechanics for policymakers who may be generally knowledgeable about the technological world but who did not progress beyond algebra and introductory physics in high school or college. This chapter explains quantum scales and starts an explanation as a very blah blah blah. So that's all about they what they are saying, that they are what they are going to make us understand in this module. So that what I have told you already. So let's start with our part 1. So that is A1. So what is a quantum? The quantum world, a brief introduction. Let's start the real introduction now. So you people all know about the Albert Einstein, a genius, a genius physicist of all time. He's the best man who have given us lots of equations and make our life simple and make us think in broader concepts of this world. Mm. What I am saying, that bef- before the time of Einstein, physicists were really, what we say, uh, really of old-minded people. They do not think differently. They have their own beliefs. They work on the what Newton have provided. They work on the things only for that. But Einstein came. He changed maximum of the physics, and today also people admire him for his theories, for his equation that uh, he have gifted to this world. So I am also admiring him, Albert Einstein. Sir, thank you for providing us these equations and theories which make our lives good, in the sense we, if we use that in a good state, if we use that equations or the knowledge in the bad work, then it is a very very dangerous thing. Because as you know, the equations that have given by Einstein is used in bombs making, like atomic bombs making, and they are really destructive. They can destruct a whole country. Even are if they are used in massive quantity, they can they can make this planet, what we say, extinct from the solar system. There will be no earth present in the solar system. So let's start with the introduction part. Albert Einstein, Niels Bohr, Niels Bohr is the scientist who gave the concept of electrons and protons and neutrons. Max Planck, we all know Max Planck. If you have taken non-medical in your plus one and plus two, you all know about these scientists that whose names are written here. Werner Heisenberg and others led what is known as the first quantum revolutions when they created quantum mechanical theory in the early 20th century. Their work was sparked not by a desire to understand things that were very small, but to explain phenomena that could be measured in the world of the 1890s. In shorter order, they realized that explaining these phenomena required rethinking their understanding of matter, energy, even the time. So, to do so, they used a combination of physical experiments that are carefully constructed so that their results depend upon the integration of quantum forces. The experiments and their interpretations made by these physicists had profound consequences: fission and fusions, bombs, and quantum weapons. Other quantum devices powered by the first quantum revolution include the atomic clock, lasers, and the transistor. The medical imaginary technologies such as magnetic resonance imaging, that we call MRI. So what MRI does, it helps to make the picture of our internal organs using MRI, that is a magnetic source through which we can make a picture, make an idea about our internal organs. The place of QIS innovation is increasing so much so that the Jonathan Dowling and Gall Melbourne have labeled the current age the second quantum revolution. And this second revolution technology leveraged the special physics of the very small and minor physical phenomena and time, more precisely quantum metrology, to create imaginary or otherwise sense phenomena invisible to ordinary light. Quantum sensing and communicate information, including more secure encryption keys, quantum communications, and to engage in computing, quantum computing. So in writing in 2002 and 2003, Dowling and Melbourne attributed the second revolution to the need of the mini miniaturization and to the potential performance enhancements that QIS provided over the technology governed by the classical physics. Manu- Today many durations and performance continue to be the important driving factors, but other political imperatives and technology developments have emerged to distribute the uh, to the second revolutions. Quantum theory seems perpendicular because humans have experienced to the subatomic world in life. Quantum physics is the communicative and difficult to grasp. Unfortunately, this means that the label quantum frequency becomes smoke screen for cap strap when learning about QIS. It is important to distinguish a recent discussion of quantum effects from quantum fiction designed to entertain, confuse, or distract. Quantum factors is readily seen in Hollywood movies where a superhero might pass her hand through a wall, explaining, well, we are mostly made up of empty space, and then perhaps adding a throwaway explanation that her hand is making use of quantum tunneling. This seems reasonable because the atomic nucleus is in the trinity compared to the size of the atom, and quantum tunneling is a real phenomenon. Quantum tunneling appears to particles to skip through barriers. It is the basis of scanning, tunneling, microscopy, and it's present a fundamental limit to how small the features of integrated circuit transistors might actually get. But quantum tunneling only happens at the subatomic scale. In real life, a superhero cannot phase through the wall because the electrons in the hero's hand repel electrons in the wall. That is why the quantum fiction is a superhero movies relies on quantum graphics to add the visual effects rather than relying on the quantum physics. So this was the introduction part. So let's start with our main concept of quantum theory. So terminology, size, and frequency. So that is the heading of the second part, A2. This section introduces the terminology of modern physics and where is a sense of a size involved. Hydrogen is the simplest atom with a single negativity charge electron orbiting around a positively charged nucleus that contains a single proton. Because it has a single proton, the hydrogen atom is said to have atomic weight of 1. So that is 1 U or we can say 1 AMU, that is atomic weight. Hydrogen gas is a molecule that consists of two hydrogen atoms. The two nuclei each consist of a single proton and two electrons are shared between them, forming what chemists call a covalent bond. So covalent bond are bond which are made between the two atoms. One atom is there and other atom is there. Both make bond with each other, not one like one atom is holding the other atom. Not that they are one atom is holding the other atom is holding the other. Suppose we have two atoms A1 and A2. Both have their own bonds. A1 has A1 bond and A2 has A2 bond. So you can imagine how they are entangled with each other. So a small fraction of the hydrogen small factor of the hydrogen on the planet has both a positively charged proton and a neutrally charged neutron in its nucleus. This kind of hydrogen is called deuterium and it has its atomic weight of 2. Water made from deuterium is called heavy water. Played a role in German atomic bomb program in World War II because it can use as a moderator to sustain a nuclear chain reaction. Is a critical step in producing plutonium. It is also used in medical research to measure food intake and energy balance. A third kind of hydrogen called tritium. It has two neutrons. Tritium is highly radioactive because the atom's nucleus has twice as many neutrons as protons. Nuclei become unstable if the neutron proton ratio is more than 1:1. Tritium has been used in self illuminating mechanical watch dials and as a transfer in medical dialogue. It is also an indicator that contain kind of nuclear weapons. Quantum mechanics describes protons and nucleus with mathematical equations that define a probability distribution instead of thinking of electrons buzzing around the nucleus like planets surround the sun. Think instead of an electron cloud surrounding the nucleus like a swarm of bees buzzing and a hive. But even that analogy is flawed mathematically. The hydrogen electrons is better better described with the equations that describe the wave of center on the atomic nucleus like the vibrating surface of the bell that have been stuck. The equation describes how the electron energy charge change when it absorbs light. Quantum mechanics also describes how hydrogen atom resemble a spherical shell with a diameter of approximately 1.1 is centered on the hydrogen nucleus. The nucleus is described with a similar equation except that it has a diameter of 0.000017 Armstrong, that is 1.7 into 110 raised to power minus 5 Armstrong or minus 15 between that. So the hydrogen electrons can be anywhere, no space within the atom is strictly empty. Look at an even smaller scale and even empty space within the atom as well as the empty space between atoms and may be filled with the observed space time functions. Quantum form in which mass and energy is created and destroyed in a manner that it consistent with the Heisenberg uncertainty principle. So that is a very interesting principle of given by the Heisenberg. If you wish, we may discuss about this uncertainty principle in our upcoming videos. So let's start with our next topic, that is 8.2.2, that is quantum sizes. Previous sections, the previous section measure the measurement like a 1.1 Armstrong without much reflection. These sections attempt to provide a better understanding of sizes. So this chapter will be going to understand about the sizes. So we may skip this section because here we come to know how small are the atoms. That is our not our topic. So if you are interested, you can pause the video and read it by yourself. So that is we don't know, we don't uh, want to make understand you all that why the size we do matter. We are here to understand the concept of quantum realm. So here they discussed about the size is how I imagine how they are making us to imagine the size of the atoms, how small are they. So let's come to our next topic, that is light. So what is a light? It is a very interesting topic, so please listen this carefully. So let's discuss about light. The fundamentals of light are a focus of early educations. For example, a mixture of all the colors in a rainbow, and what we call a rainbow is actually a drop of a rain acting like a prism, splitting sunlight into its component colors. On the other hand, students who take theater class we'll learn that what looks like a light can be a profound in mixing red, green, and blue light together. That works because the most people I have three kind of color sensing cells sensitive to red, green, and blue light respectively. L- Light can be filtered by color. Shine white light into a red filter and red light comes out the other side. But light of one color cannot be changed into another color. Pass red light into a blue filter and nothing comes out. For many years, scientists were confused about the fundamental nature of light. Some scientists, like Isaac Newton, thought light was made up out of tiny objects he called corpuscles. Other scientists, like Thomas Young, thought that light was actually some kind of wave traveling through some kind of medium, variously called the ether, also written ether, ether, or even in geek language. If you happen to write Asian geek, if you use a prism to produce a rainbow, you will discover that somehow sun's energy extends on both and beyond the familiar red, orange, yellow, green, blue, indigo, violet. That is, there are seven colors of the light. If we pass it through the prism, that we may call it whipped cure. If we if we mm, if we read it from the last alphabet, then it is Vibgyor. Color chart. Place your hand on the left of the red and your hand will grow. So through a glass darky. So if we pass light through a glass, then if in the suitable condition we come to know about the splitting of light in different colors. That what they are making us to understand here. Quantum physics is replacing the imperfect mirror called classical mechanics. The imperfect mirror allowed us to leave many questions to prosperity, prophecy. As a quantum physics mirror is perfected, what will be left on prophecy? So different colors of light have different frequency, and according to that they travel. So red light has the most least frequency. Light frequency is denoted by lambda, so it has very least lambda. And blue has the most frequency, that is very much frequent to light, frequent wavelength blue color forms. So let's discuss about the speeds of quantum particles. So light is one of the best understood quantum objects in the in part because of its simplicity, it in part because it is easier to study, and in part because humans can observe it. In ancient time, people thought that light moved instantly, but in 1670s, the Danish astronomer Ole Rommel determined light must have infinite speed based on the observations of ellipse of Jupiter moon. Low Romer's estimations of the speed of light was about 2 2000 kilometers per second, roughly three quarters the actual value, that is 3 lakh kilometer per second. An approximation. All colors of light travel at the speed as to radio waves, microwaves, and gamma rays. It turns out that beam of micro uh, monochromatic light also has a wavelength and frequency. They are related by the equation. So C is equal to lambda f. So here is the equations that is written about what are the values of c and lambda and f. So c here represent the speed of light, roughly about 3 lakh kilometer per second. Lambda is the wavelength of light, and f is the frequency of light. So this is the formula to calculate the speed of light, or anything that is missing, and two things are given here, then we can find the third thing. So they are interrelated with each other. This is the wavelength times frequency equations that we have discussed. So here are some of the measurement given. So for wave radio, its wavelength is this and frequency is this. There are different waves and rays. Their frequency is written here. Their wavelength is written here. If you have any, if you want to, it is not important uh, to learn it. You can see and make a sense of it, and that what are these, how how fast and how energetic different rays are, and how their frequencies are. So here they have written that table A1 shows that is A1, that is this table, we have discussed, that these are the frequency and wavelength of different colors. There are the frequency and wavelengths of different rays and waves. So if we see different colors like violet, it has a wavelength this, and this. If you see blue color somewhere, it has this frequency, and this. These are the stuff. So you can imagine how their speed and wavelength are. Table. So let's go further. Table 8.1 shows the wavelength and frequency for the various kind of light. Notice that invisible light does not um, uh, allow the and does not follow the convention of falling within the powers of 10. Unfortunately, visual light does not fit neatly into the table. Our eyes involved to preserve light in the relative tiny light range of light, that was wavelength of 380 nanometer to 740 nanometer as shown in table 8.1. This exposition of reveals an important point: the quantum realm, and almost all the this exposition reveals an important point: the quantum realm, and almost all the effects happen outside the human perception. We perceive the world through the glass darkly, a glass that only reveals visible light. The quantum world and quantum effects typically require special equipment to perceive and manipulate. As a result, we have little day-to-day experience with quantum world, and its attributes are thus counterintuitive and take work and study to learn. The appendix introduce the basic. Here we learn about the basics of quantum realm, and appendix covered the reasons why quantum information science is acting, the relative sizes of quantum phenomena, fundamental properties of light, the idea of everything was wave, and the particle-like properties. The foundation is very necessary for next appendix. I will be doing some of the topics about quantum physics in the next videos. So keep going with me, and if you are not subscribed to my channel, subscribe to it. And if you like this video, like it. I will be making more of videos like this, more informative, that will help to broaden your concept of physics in your mind. So this is the video. Here I have not used any graphics, any animation, or any of the editing. It is the video that I have recording, simplest to the simplest. uh, so if you motivate me, if you like this video, subscribe, and this will motivate me to make more videos, more give it more time, give it more energy, and invest in that video. So if you do understand, if you like this video, please like, and I will be back with another concepts of physics. So that's all in this video. Hope you are well and enjoying your life. So tada, bye.